Now we will see the terms system. What is a system? What are surroundings? And what is universe in thermodynamics? Okay. What is a system? System is that part of matter which we are interested in. Okay, whose changes we are going to study. Okay, you take some cylindrical vessel fitted with some perfectly frictionless movable piston. You take some 1 mole of some gas here, or any liquid or any solid, whatever it is. That part of matter which is under study, okay, whose changes we are interested in, right, is known as system. Okay, here this gas is my system. Okay, now what are surroundings? Anything with which our system is in, what you call system interacts with, is known as surroundings. Okay, interaction means what? System should be in a position to give something or take something. Okay, right? Suppose a system is exchanging heat, means I can put this vessel on the stove and heat it. Okay, system gets heated up, means system is taking heat energy, means our system is interacting with the stove, right, by taking heat from it. Or right, suppose it gives heat into the surroundings. Okay, anything with which our system gives something or takes something is known as surroundings. Surroundings means not simply those which are present, okay, outside. Okay, system should be in a position to interact with. Interaction means what? It should be able to give something or take something. Okay, those things are known as surroundings. Okay, system plus surroundings, right, system plus surroundings in thermodynamics known as universe. Okay, is known as universe. Universe means, don't think that it is sun, star, solar system, etc. No. Okay, system plus surroundings. What is a system? Right, the part of matter in which we are interested in is known as system. Anything with which our system interacts, means by giving something or taking something, means mass or energy, they are known as surroundings. System plus surroundings is simply called as universe. Okay, now how many types of systems are there? We come across 3 types of systems actually. Okay, right, one is a closed system or open system to begin with. Open system. Okay, closed system. Systems are of 3 types. And isolated system. Isolated system. Okay, now you take some beaker or some vessel, put some water inside it. Okay, right, and you put it on a stove and start heating it. Okay, now heating means what? System means our water is taking heat energy from the surroundings. So system is in contact with the surroundings. We say the stove or what you call other things with which our system is interacting is known as surroundings. Okay, now I can add, if I wish, I can add some water to it, or I can take out some water from it, or I can give some heat energy to it, or I can put this entire vessel in a refrigerator and cool it down. Cooling it down means what? I'm taking heat from the water. Okay, means I can give some matter to it, or I can add some matter to it, or take out some matter. I can give some heat to it or take out some heat to it. Means this system is what you call interacting with the surroundings by the exchange of both mass and energy. Okay, both mass and energy. Such a system is known as an open system. An open system is one which exchanges both mass and energy with the surroundings, is known as an open system. Okay, right, now in another case, take a cylindrical vessel fitted with a frictionless, perfectly movable piston. Okay, there is some gas inside. Okay, right, now I cannot add any gas or take any gas from the system, but I can put it on a stove and heat it, or I can put the entire vessel in some refrigerator and cool it down. Means I can give heat or take heat, but I cannot add any gas or remove any gas. Means here there is no exchange of mass with the surroundings, only exchange of energy is taking place. If only energy is exchanged between the system and surroundings, only energy is exchanged between the system and surroundings, such a system is known as a closed system. In a closed system, the quantity of matter under study remains constant. In an open system, we can add some mass or take out some mass. We can give some energy or take some energy. Okay, this is an open system. If I can exchange only energy with the system without mass, that is known as a closed system. Okay, now suppose it is, you take a vessel which is having insulated walls. Okay, it is an like wood or what you call thermocol or something like that. Here, what you call the system is a closed one. You cannot add any gas or take out any gas. Means no mass can be exchanged with the surroundings. Say you cannot heat it or cool it down. Okay, means if what you call neither mass nor energy. Okay, right? If mass and energy both cannot be given or taken, such a system is known as an isolated system. Okay, for an isolated system, right, you cannot give any mass or take any, increase its mass or decrease its mass. You cannot give any energy, take out any energy. If neither mass and energy are exchanged with anything, such a system is known as an isolated system. If only energy is exchanged, it is a closed system. Both mass and energy are exchanged, it is an open system. Now, how did we define what you call universe? Universe we have defined as system, okay, plus surroundings is equal to universe, I told. Okay, is equal to universe. An open system is exchanging both mass and energy. Okay, means it has surroundings. A closed system, though mass cannot be exchanged, energy can be exchanged. Means closed system also will have surroundings. But what about an isolated system? Isolated system is not exchanging any mass or energy with anything. Okay, means isolated system is not having surroundings. What are surroundings? Anything other than the system with which our system interacts is known as surroundings. Okay, that isolated system is not having any surroundings because it is not exchanging anything with the surroundings. So isolated system will not have any surroundings. So isolated system itself becomes universe. Isolated system itself becomes universe. So system plus surroundings equal to universe is equal to isolated system. Okay, what is a system? What are the surroundings? What is the universe? These three will become very useful when we go into second law of thermodynamics, when we are discussing the topic called entropy, right? There the questions will be coming. What is the change in entropy of the system? Change in entropy of the surroundings? What is change in entropy of the universe, like that? So what is a system? What are surroundings? What is universe? We should be able to identify clearly. Okay, right? There these things will become very crucial. Okay, mostly throughout our thermodynamics, okay, we'll be talking mostly about closed systems or isolated systems. Okay, right? We'll take some fixed amount of matter and study the changes and try to understand the properties of that matter. Okay, so we don't keep on adding mass or taking any mass. We'll take some fixed mass, see what all changes are occurring, what are the properties of the system thermodynamically. Okay, right? So we'll mostly throughout our discussion, right, in thermodynamics, right, it will be closed or isolated systems. Okay, now you take some system. Okay, let it be a closed system or a closed system you take. Okay, because we should be able to give heat or take heat. Okay, some cylindrical vessel with a gas inside and a piston here which can move up and down. This is a conducting vessel, say. This is a conductor. Okay, now I want to study the system. What do we mean by studying a system? Okay, means we'll understand some of its properties. We'll study first, we'll measure what are the properties. So studying me, so somebody asks you to study me, what do you do? Studying means what do you understand? What is my height? What is my weight? Okay, and of course, what do you do with my height and weight? You are not interested in my height and weight, no, isn't it? You are interested in what I am teaching, how I am teaching, etc. So studying me from a student point of view, studying a lecturer means how well he teaches, okay, how much he is teaching, for what exam he is teaching. These are the things which we will be studying. Okay, means some properties of mine with which you can understand something about me. Similarly, there is a system here. Okay, system will have some properties called thermodynamic coordinates or state variables. Thermodynamic coordinates or state variables, we say. State variables. Okay, what are they? Like temperature is one state variable. Okay, pressure of the gas is another variable, and volume of the gas is nothing but volume of the vessel. Okay, so temperature, pressure and volume, okay, at this point are these thermodynamic coordinates or state variables. by studying them, right, we'll understand something. The system is at so and so temperature, system is at so and so pressure, system is in so and so volume. They denote the state of the system. They denote the state of the system. By simply knowing the temperature, pressure and volume, we won't understand anything about the properties of that gas. So what do? Studying means what? Studying means what? Means you will change one property of the system in one way and see how other properties are changing. Okay, studying me means simply you are there and I am there. If you keep on looking at me, you won't understand anything about me. Okay, you understand what type of person you are, what are you supposed to do. You have to bring some change in me. Means suppose you should come and slap me like this. Okay, if you come and slap me like this, the way I react, you will understand what type of person I am. Similarly, you have to change something, or you have to come and pinch me once. Okay, if you pinch me once, the way I react will let you know what kind of a person I am. Okay, if you slap me once, I show you my second slap, oh, he's as great as Gandhiji. Okay, if you slap me, again I slap you, oh, this fellow is a very aggressive fellow. Okay, like that, you will understand something depending on my reaction. Similarly, right, system is having some parameters. Try to change any one of these parameters. Okay, change temperature slightly, see how pressure and volume are changing, or change the pressure on the gas, or do some work on the gas, how the system is reacting, how temperature, pressure, volume are changing. Means bringing some change in one or two parameters and studying how other parameters are varying. That is known as studying the system. Okay, that's how we will understand what type of system it is, its nature, its properties we can understand. Okay, right? So this is nothing but thermodynamics. Okay, when you give some heat, how temperature, pressure, what you call are changing, or how heat is flowing from the surroundings into the system, or from the system into the surroundings. Okay, dynamics of heat. Okay, the name dynamics of heat or thermodynamics we say. Okay, how to bring about change in temperature by heating it or cooling it. Okay, means you have to give some heat or take some heat. Dynamics of heat flow is known as thermodynamics. Chapter under thermodynamics we call. Okay, now sorry. Now, you consider a system like this. Okay, this is my system. What are the salient thermodynamic coordinates or state variables for the system? Okay, temperature. For a gaseous system, temperature is important, pressure is important, volume. Okay, these three are important terms. Okay, systems means need not always be a gas in a cylindrical vessel fitted with a piston, need not be. Okay, many types of systems can be under consideration. Okay, I can take a stretched string. In oscillations and waves chapter, we'll take one string of some finite length, attach some mass to it. Okay, will bring some tension into the string. Okay, this is also a thermodynamic system. Or I can take some what you call surface film. Okay, thin leather sheet or rubber sheet, stretch it from all sides. Okay, stretched membrane. Okay, we call that can also be a membrane stretched in all directions. All right, this can also be a surface film, just like a soap bubble or some oil flick on water, etc. They are all surface films or stretched membranes we call. This can also be a thermodynamic system. Okay, stretched string can also be a thermodynamic system. Only thing is parameters will keep on changing. Okay, right, like that. A dielectric slab can also be a thermodynamic system. A magnetic material like a paramagnetic salt can also be a thermodynamic system. Okay, or a reversible cell. Reversible cell means what? The cell, our cell phone batteries are reversible cell only. Means you can charge it and it gets discharged. Again you can charge it, it keeps on getting discharged like that. It is known as reversible cell. Okay, that is also thermodynamic system. So, but different thermodynamic systems have different variables. Okay, but since this topic is thermodynamics, okay, temperature is considered in all the systems as one important parameter. Okay, a stretched string will not have pressure or volume. What are the properties of a stretched string? Length of the string is important one. Okay, next one, tension in the string, capital T. is also important apart from temperature. Like this, we have some thermodynamic systems which we will be considering now one by one. Okay, first one, we take this, we take our vessel only. Okay, gas in some vessel. What are its variables? Okay, gas in a vessel. The first system is gas in a vessel. Okay, cylindrical vessel fitted with a piston. What are the thermodynamic coordinates? Temperature is one important thing. Next one, pressure. And third one is volume. Okay, this is the first one. Second one, I'll take a stretched string, a string stretched under some tension T. Okay, because it is a topic called thermodynamics. Okay, temperature is always taken as one important parameter. Stretched string. What are the important parameters in the case of a stretched string? When we want to study a stretched string, of course, temperature is one important property because we are interested in thermodynamics. Okay, for a stretched string, right, tension in the string is important. Okay, tension in the string is an important property. Next one, its length. String will not have volume. String will have length. Okay, so what are the parameters important for a stretched string? Temperature, tension, and length. Similarly, a stretched membrane or a surface film. Okay, stretched membrane or a surface film, like an oil fleck on surface of water, or a leather one, just like in tabla and mridangam, drums, etc. Leather piece will be stretched under some tension. Okay, there what are the important parameters? Okay, again, first one always temperature. Second one, for a stretched membrane, we call it as surface tension. Okay, surface tension is one important property. Surface tension. Okay, third one, area. Okay, a stretched membrane will have area. Okay, gas will have volume, string will have length, and surface film will have area. Okay, fourth one, we can take a reversible cell. Okay, reversible cell. Okay, what are the important parameters of a reversible cell? Okay, reversible cell important parameters are again temperature. Okay, some China phones will, when you are charging them, they get heated up. When you are charging, iPhone battery will not get heated up. Okay, or a good phone like Samsung phone will not get heated up when you are charging it. Okay, but some local phones or China phones, they'll become very hot when you are charging them. Okay, that should not be the case. Actual reversible Helmholtz cell temperature should not change for an ideal battery. Okay, of course, small changes in temperature are acceptable, but not too much. Okay, so temperature is one important property for a reversible cell. Okay, next one, for reversible cell, another property is EMF. Okay, electromotive force or voltage we can call. EMF is one important parameter. Next one, the amount of charge which it can store. Amount of charge which it can store. Now batteries are coming with 4000 mAh, milliampere hour. Okay, 5000 mAh, 6000 mAh, like that. Okay, amount of charge it can contain. That is important for a reversible cell. Of course, voltage. What voltage? Pencil cells. All pencil cells will come with 1.5 volts only. EMF will be around 1.5 volts. Okay, let it be a pencil cell or a big cell or whatever it is. Most of the cells throughout the world are 1.5 or what you call 6 volts or 9 volts, and only you will be finding most of them. Okay, if you want 12 volts potential difference anywhere, 1.5 volt cells, you will add 8 of them in series so that you will get 12 volts. Okay, so EMF is one important parameter. Okay, charge is one important parameter. Temperature. Okay, next one, you can take paramagnetic salt. Fifth one, you can take this paramagnetic salt. Okay, what are the important properties of a paramagnetic salt which we'll be studying under thermodynamics? Okay, first one, again, as usual, temperature. Every parameter, temperature, because topic itself is thermodynamics. Okay, right. Next one, for a paramagnetic salt, what do we do? On a magnetic material, what do we do? We'll apply some magnetic field on it. So the magnetic field strength B bar, which we apply on the salt, is important one. Next one, when you apply some magnetic field on the magnetic material, inside some changes will occur, some magnetization will come. Okay, how much dipole moment has come inside the material, the total magnetization. Okay, we denote it by M bar usually, or more equally popular notation is I bar also. Okay, what is the intensity, or what you call the total magnetization which has come because I have applied some magnetic field, okay, is known as magnetization or if I'll take one material, I'll apply magnetic field on it. Some magnetization has come inside that material. I'll take another material and apply the same amount of magnetic field. If I get a different magnetization, okay, I'll be getting a different magnetization. How much magnetization? What is the difference between this and this? By that I can understand how magnetic this material is. What is its susceptibility? What is its permeability, like that. Okay, more magnetization, more effective magnetic material. Less magnetization, less effective magnetic material it is. Okay, so it is total magnetization or total intensity of magnetization we call. Okay, next property, next system can be a dielectric slab. A dielectric slab. Dielectric means what? An insulator, just like a piece of glass or a piece of rubber, a piece of cloth or a piece of paper, whatever it is. Some dielectric material you take, which is an insulator. Thermocol sheet you take, that is also dielectric material. Okay, right? What are the important parameters of a dielectric slab? Of course, as usual, first temperature. Okay, next one. On a dielectric slab, we don't apply magnetic field, we'll apply electric field. Okay, so the intensity of the electric field, E bar. Okay, next one, right? When I apply some electric field on a dielectric material, some changes will occur. Some electric dipole moment gets induced inside the material. That is known as dielectric polarization. Okay, the total amount of dipole moment, okay, that's called dielectric polarization, P bar. Okay, for what field, how much polarization, how much electric dipole moment I am getting, that's important. That's known as dielectric polarization. These are some important thermodynamic systems which we can consider in thermodynamics, and the corresponding what you call thermodynamic coordinates are state variables which describe the properties of the system. Now, out of these, okay, variables, I'll classify some materials as some variables as, okay, intensive variables and extensive variables. Some are intensive and some are extensive variables. What is an intensive variable? An intensive variable does not depend on the amount of matter. Okay, a variable which does not depend on the amount of matter present is known as an intensive variable. A parameter which depends on the quantity of matter is known as an extensive variable. Okay, for example, you take this pen. Okay, this pen has some length and it has some quantity of matter inside it. Okay, without disturbing its shape, suppose I'll cut this pen into two parts. Which properties of the pen will change, which properties of the pen will not change? The property which obviously changes is its length. Okay, its length. But when I cut this pen into two parts, its temperature will not change. Suppose I take the important parameters of this pen as temperature, length, and some tension or something like that. Okay, when I cut this pen into two parts, okay, length only changes, length becomes half, but temperature of the pen will not change. Temperature does not depend on the quantity of matter present in the sample. So temperature becomes an intensive variable, length becomes an extensive variable. Length depends on the quantity of matter present. Okay, you take some what you call a cylindrical vessel and some gas here. Okay, now you want to reduce the quantity. If you reduce the quantity of matter by half, means suppose you cut it down like this. Okay, such that earlier, suppose 1 mole of gas is there. Now you are taking half mole of gas. Now you are taking half mole of gas only. Okay, which properties of the gas has changed? Temperature will not change. Pressure of the gas will not change. Okay, but volume of the gas will change. Without changing pressure, you can simply reduce. Means if this room is there, in this room, air is at some temperature, air is at some pressure. Okay, the room has some volume or air has some volume. If I construct one wall, right, such that I'll divide this room into two equal parts, which properties staying out of temperature, pressure, volume, which properties change, which properties do not change? Temperature of the room will not change if I construct one wall halfway between. Okay, pressure of the gas also will not change. What changes is only volume of the room becomes half, volume of the gas becomes half. So volume depends on the quantity of matter without changing temperature and pressure. Okay, so temperature and pressure are intensive variables. Volume of the gas is an extensive variable. Similarly, in the case of a stretched string, okay, in the case of a stretched string, temperature is always an intensive variable. Okay, tension in the string also is an intensive variable because tension depends on the amount of mass you are hanging from the string. Amount of mass you are hanging from the string, right? But when you cut the string into two equal parts, its length becomes half. Means if you reduce the quantity of matter in that string, right, length is going to change. So volume in the case of a gas, length in the case of a stretched string are extensive variables. Okay, temperature and tension, temperature and pressure are intensive variables. Similarly, for a surface film, temperature is an intensive variable, surface tension also is an intensive variable, but right, area becomes an extensive variable because you cut that sheet into two equal parts, right, area becomes half. But temperature, what you call surface tension, depends on the amount with the tension with which you are pulling it from all sides. Okay, so this is an extensive variable. In the case of a reversible cell, again, temperature is an intensive variable. EMF is also an intensive variable. Okay, EMF does not depend on the quantity of matter present. See, whether you take small pencil cell or a big cell, okay, right, or a very big battery also. See, our motorcycle battery, Activa battery will be very small. Okay, whereas car battery will be this big, lorry battery will be this big. Okay, but all will have voltage of 12 volts only. Okay, EMF does not depend on the size of the battery. Okay, EMF is an intensive variable. But charge, why lorry requires a bigger battery? Because it has to drive more charge, more current. Okay. For a lorry also 12 volts, my Activa is having 12 volts battery only. I cannot run a lorry with my Activa battery, or I cannot run a car with my Activa battery. Why? Car requires more current to be driven. So, okay, more charge should flow out of that battery, means the amount of matter should be more. That's why when you want more and more current for a given EMF, right, the size of the battery keeps on increasing. Size of the battery depends on the amount of material inside. The more the amount of metal inside, the more the charge driven, more will be the current. Okay, so charge depends on the quantity of matter. Whereas EMF, you take a small pencil cell or small Activa battery or a big lorry battery, EMF will be 12 volts only. So EMF is an intensive variable, charge is an extensive variable. Similarly, in the case of paramagnetic salt, temperature is intensive, intensity of magnetic field. You take a small material or a big material, right? I can apply the same magnetic field on them, no, isn't it? Okay, so B also independent of mass, but right, the quantity of magnetization. If there are 1000 atoms present in the sample, 1000 atoms will get magnetized. I'll get one dipole moment, one magnet dipole moment. If there are 1 lakh atoms in the material, I'll get more dipole moment. Okay, so magnetization depends on the quantity of matter present or number of atoms present or quantity. Okay, so magnetization is an extensive variable, right? Temperature and B are intensive variables. Similarly, in a dielectric slab, temperature and electric field. Okay, electric field value depends on, I will decide how much electric field I should apply. But for a given electric field, how much electric dipole moment is getting induced? If there are only 100 atoms, some dipole moment will come. If there are 10,000 atoms, more dipole moment will come. So, right, polarization, total polarization of the material depends on the quantity of matter present. So, this is an extensive variable. Magnetization is an extensive variable. Charge is an extensive variable. Okay, area, length, volume, these are extensive variables. Remaining things are all intensive variables. Okay, so all these can be considered as thermodynamic systems only, but throughout our course we'll mostly talking about, right, gases in a vessel. Okay, we'll take different types of gases in a vessel, right, bring some changes, because in a gas we can take the same thing with liquid and solid also, but in a gas, if you give small amount of heat, appreciable changes will occur in temperature, pressure and volume. You take this pen and give some 100 joules of heat, you don't see much change in its volume or in pressure or not much in temperature. You take a small sample of gas, you give some amount of heat, temperature, pressure, volume change appreciably. So mostly in our case we will be discussing with gases mostly. Sometimes wherever required we talk about liquids and solids also. Okay.